Thermodynamics in Biosystem Module 2 Basic Concept of Thermodynamics Segment 6 Problem Solving Technique with me Yusuf from School of Life Sciences and Technology, Institut Teknologi Bandung. Previously, we have discussed about system and its properties, state and equilibrium, processes and cycles, as well as temperature and pressure. In this segment, we will discuss about problem-solving technique. Problem-solving technique. The first step in learning any science is to grasp the fundamentals and to gain a sound knowledge of it. The next step is to master the fundamentals by testing this knowledge. This is done by solving significant real-world problems. Solving such problems, especially complicated ones, requires a systematic approach. By using a step-by-step approach, an engineer can reduce the solution of a complicated problem into the solution of a series of simple problems. There are 7 steps-by-steps that can be applied when solving a problem that will help to avoid some of the common pitfalls associated with problem solvings. Step 1. Problem statement. Using our own words, briefly state the problem, the key information given, and the quantities to be found. This is to make sure that we understand the problem and the objectives before we try to solve the problem. Step 2. Schematic. Draw a realistic sketch of the physical system involved and list the relevant information in the figure. The sketch does not have to be something elaborate, but it should resemble the actual system and show the key features, indicate any energy and mass interactions with the surroundings. List the given information on the sketch helps one to see the entire problem at once. Also, check for properties that remain constant during a process and indicate them on the sketch. Step 3. Assumptions and approximations. State any appropriate assumptions and approximations made to simplify the problem to make it possible to obtain a solution. Justify the questionable assumptions. Assume reasonable values for missing quantities that are necessary. Step 4. Physical laws. Apply all the relevant basic physical laws and principles such as the conservation of mass and reduce them to their simplest form by utilizing the assumptions made. However, the region to which a physical law is applied must be clearly identified first. Step 5. Properties. Determine the unknown properties at known states necessary to solve the problem from property relations or tables. List the properties separately and indicate their source if applicable. Step 6. Calculations. Substitute the known quantities into the simplified relations and perform the calculations to determine the unknowns. Pay particular attention to the units and unit cancellations. A dimensional quantity without a unit is meaningless. Step 7. Reasoning, verification, and discussion. Check to make sure that the results obtained are reasonable and intuitive, and verify the validity of questionable assumptions. Repeat the calculations that resulted in unreasonable values. Also, point out the significance of the results and discuss their implications. State the conclusions that can be drawn from the results and any recommendations that can be made from them. Emphasize the limitations under which the results are applicable and caution against any possible misunderstandings and using the results in situations where the underlying assumptions do not apply. Beginners are strongly encouraged to follow these steps in problem solving. In the next modules, we will discuss about energy. Until then, I am Yusuf from Institut Teknologi Bandung.